Alright guys, make sure you put your name on your paper to make sure I know whose it is when you turn it in. We have a test tomorrow, the 29th. It's going to be 20 questions. 8 of them are going to be expressing roots, and that's when we have the radicals, and you're getting them into prime factorization. You're pulling out the numbers. And the other is the law of exponents. There's going to be 8 questions on the law of exponents. That's what we're going to do first. And then we have 4 review questions. 4 review questions, a little high, but it made it up to 20 questions, so every question is going to be worth 5 points. So let's go through the laws of exponents first. Alright? So, the laws of exponents are this. The multiplication rule, you're going to add your exponents. Okay? We're going to show these in more detail later, but the multiplication rule is F. Okay? X plus Y. If X and Y are your exponents, you're going to keep the base, add the exponents. The base must be the same. Your division rule is exactly the opposite. Your division rule is you're going to subtract the numbers. Okay? So, your division rule is that if your bases are the same and they're on top of one another, so you have an A to the 4th power on the top and an A to the 2nd power on the bottom, you're going to subtract the exponent. So it would equal A to the 2nd power because 4 minus 2 is 2. The power of the power rule, power of a power means that you're going to multiply them together. So multiplication is adding, division subtraction. The power of a power rule is D. You have a base and you're going to multiply the exponent by whatever the power is on the outside. Okay? The next one, the power of a product rule, it's very similar, except this only says that if you have 2 separate bases, like an A and a B in this case, then your exponent goes to both the A and the B. So the power of a product rule is really just an extension of the one we just discussed. And it just merely states if there's 2 bases that you are going to have the exponent on both bases. The zero exponent. The zero exponent rule, in my opinion, is the hardest because you either know it or you don't. If something is raised to the 0 power, it is 1. It doesn't matter how many numbers you have, but if it's raised to the 0 power, your answer is always going to be 1. So 5 is C. And number 6 says the negative exponent rule. You can never have a negative exponent. This is one that we've kind of struggled with this week. If your exponent in the top is negative, you bring it to the bottom, your denominator. So if your numerator is negative, you bring it to the denominator. And if your denominator is negative, you bring it to the numerator. So, if you end up with a negative exponent, you are going to make sure that you flip it to the flip it on the fraction. So again, if it's in the numerator, it will go to the denominator. If the negative exponent's in the denominator, you're going to go to the numerator. Okay, so that one's tricky. The last 2, in my opinion, are the hardest. The zero exponent rule and the negative exponent rule, in my opinion, is the hardest. But let's go ahead and work on number 2. Number 2 says adding like polynomials. Okay? Remember, to add like polynomials, adding and subtracting, the bases must be the same. Okay? And the way we described this earlier this week is that we looked at our algebra tiles. You know, this we learned last week was x squared, and we learned this last week was x. You cannot combine these 2 things. They're not the same thing. So the same thing with polynomials. You cannot combine them unless they're the same thing. In this case, you have x squared, y to the 6th power, x squared, y to the 6th power. So that means they're exactly the same. So we can, in fact, add those. That's going to be 17 x squared y to the 6th. Okay? So that one was pretty easy. But remember, if those bases aren't exactly the same, you cannot add them. The next one we're going to go over is the multiplication rule. Okay? The multiplication rule states that we're going to multiply any number as long as it's not acting as a base, and then you're going to add your exponents. So we've done this, we've broken this up all week. Okay? So we've broken up, we have 8 times 2 Those are our two numbers. Our letters are x and x squared, and x squared can be written x times x. And then your y's, you have 4 y's, 1, 2, 3, 4, and you have 2 y's on the other side, 1, 2. Well, if you break it up like this, it actually is, in my opinion, much easier, because now all you have to do is count them. Okay, so we have 8 times 2 is 16, and we have 1, 2, 3 x's, so it's x cubed, 1, 2, 3, 4, 5, 6, y to the 6th. Okay? The other way you could have looked at this is you could have said x to the first power is 1, x to the second power is 2, just added those two together. Y to the fourth power, y to the second power, you add those two together, and you will get 6. So, number 3 is 16, x to the cubed, y to the 6th. Number 4 is division. See how I'm just going down rule by rule? Division is that you subtract. My recommendation is that you rewrite this so that it's over top of one another. So you have your 8 and your 2. You have x, 1x, 2x. In fact, I'll even put these in a different color so you see it better. So you have 1x, 2x, 3x, 4x, 5x, 6x, 7x. Then the x's on the bottom is 5. 1, 2, 3, 4, 5. Okay, I'm going to extend my division line a little bit more. And now we have our y's. Y's, you have 1, 2 on the top and 3 on the bottom. Okay? Now, a lot of you guys just want to subtract these, and you might end up getting them wrong if you don't know if the x is on top or the x is on the bottom. So, the way we've done it in class, we've divided this. 8 divided by 2, I know it's a fraction and it freaks us out, but if you divide this by 2 and that by 2, 2 divided by 2 is 1, 8 divided by 2 is 4, so you have 4 over 1 technically. You don't have to write the 1 if you don't want. So, then you have your x's. We're going to get rid of the x's as we go. 1, 2, 3, 4, 5 of them go away. 7 minus 5 is 2. So you have x squared. That's how many you have left. You have 1, 2 left. And then you have y. So we're going to scratch these off. 1, 2. We have a y left. But this is the trick. That y is on the bottom. So we've got to leave it on the bottom. So that stays down there. Because if you were to subtract 2 minus 3, you get negative 1. And y to the negative 1 is a negative exponent. So you'd have to flip it down from the numerator to the denominator. So our answer would be 4x squared over y. That would be our final answer to that question. Okay, so that one's a little tricky. I tried to trick you with that y at the bottom. So just make sure you're either subtracting and understanding that negative 1 goes to the denominator, or you draw it out and you see that you have a 1 at the bottom in the denominator that way. So let's look at the power of the power rule. Power of the power is the one that tricks us. So what I've told you guys to do is whatever this number is, that power on the outside, you're going to write it that many times. So in this case, we're going to write 4x squared y to the 4th times 4x squared y to the 4th. I've written it 2 times because that's what it told me to do. Now it's just simply a product rule. Okay? Because I did this, I kind of avoided the power rule, and I went right to the product rule. Again, that's what we've done all week in class. Let's see here. We have a 4. 4 times 4 is 16. You're going to multiply the numbers. Okay? X's, you have x squared and x squared. That means you have 2 x's here and 2 x's there. That's 1, 2, 3, 4 x's. So it's x to the 4th power. Okay, then you have y. Y to the 4th. Y to the 4th. That's 1, 2, 3, 4 y's. 1, 2, 3, 4 y's. That's 1, 2, 3, 4, 5, 6, 7, 8 y's. Y to the 8th. Okay? And that will be your final answer. I know I put it in different colors, but I wanted you guys to see you cannot combine numbers and variables. All right? Now, the power of a product rule. Power of the product rule is pretty much the exact same thing. I'm going to do it exactly the same way. Again, I could just do 3 times 3 times 3 and then x to the third. I can do it that way because it's multiplication. But the way I recommend that you guys do it is that you see that number is 3. So we're going to say x to the third times x to the third times x to the third. Okay, we're going to put it in expanded form. Okay, so 3 times 3. So we're going to pull these out. I have 3 times 3 times 3. 3 times 3 is 9. And 3 times 9 is 27. So 3 times 3 is 9. 9 times 3 equals 27. Okay? And then you have x's. You have 1x, 2x, 3x's. So that's your total number of x's. That's x to the third. Okay? So now what we're going to do is we're going to combine all these rules. The place I like to get is to get as much of this product stuff as I possibly can. Alright? So this product rule is going to look like this. I'm going to rewrite the top, and then I'm going to rewrite the bottom. Alright? So it looks harder than it is. So it's going to be 2xy, because there's 2 of them. And then right here, it has times, there's 2 of these as well. So I'm going to write these again. 2x to the third, y to the fourth. Now this one right here says z to the 0 power. I know that's 1. So I can just take that off right now, just so it doesn't confuse me later. And then I have 2x cubed y to the 4th power. Okay, again, I'm taking the z away because it's a 1. This is going to, so what I'm going to do now is I'm going to solve this part of the problem. And then I'm going to come back and I'm going to solve the denominator. So I have 2 times 2 times 2 times 2. So 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that this number is 16. Then I'm simply going to add my x's. 1, 2, I have 3 here. 3, 4, 5, 6, 7, 8. Okay? So I have 8 x's. Okay? And then I have my y's. I have 1, 2, then I have 4 here. 3, 4, 5, 6, 7, 8, 9, 10 y's. Okay, now I just put my y's in there. So y to the 10th power. Now, I'm going to get this bottom part of it and put it underneath. Again, I've done the entire top. Now I'm going to do the bottom. So now I have 8, and I'll put it in red so they match. 8 x to the 2nd, or x squared, and then you have y to the 7th power. Okay? And then you're simply going to simplify. This is a quotient rule. Quotient rule means that you are going to subtract. But the first thing we're going to subtract the exponents. Excuse me. So the first thing you're going to do is you're going to reduce that fraction. 16 and 8. 8. I always look at that bottom, the smaller number. I can divide 8 by 8, and I can divide 16 by 8. 16 divided by 8 is 2. That makes it 2 over 1. X to the 8th, x to the 2nd. So I have 8 minus 2 is 6. And I have y to the 10, y to the 7. So that's going to leave me with y to the 3rd power. Again, I could have drawn that out if I wanted to. Said 1, 2, 3, 4, 5, 6, 7, 8 x's over 2 x's. Cross those out. That left me with 1, 2, 3, 4, 5, 6 x's. And I could have done that with the y as well. A lot of you guys are visual. 5, 6, 7, 8, 9, 10 over 7. 1, 2, 3, 5, 6, 7. Cross all those out. And that's y to the 3rd. Okay? So I can do it either way. Either way is right. Alright, so now let's just hit this review stuff and we're about done. So, that is as hard as you're going to see. It's number 7. That's probably even harder than you're going to have on your test. So, we're going to simplify these. So, I'm going to simplify them for you real quick. 350. So, I have 350. All right. Now, I want to do this quick in my brain if I can. I know it ends in 0, so I know that's going to be a 10. I know this is 35. 35 times 10 gives me 350. Okay? So whenever you're done, you've got to make 350 your number. Okay? So 35 is going to be 7 and 5. And 10 is going to be 5 and 2. So I'm suggesting that 7 times 5 is 35. 35 times 5 is 175. And 175 times 2 is 350. Okay, so these numbers, these prime numbers, do in fact equal 350. What I'm going to do now is I'm going to circle the pair. The pair comes out, so that's going to be a 5. Then I have my radical sign. And the things that go in the radicand are the things that are left over. I have a 7 and I have a 2 left over. We're going to multiply those together, and that gives me 14. Okay, so I kept that red so you guys would see it. Now I'm going to go to my variables. My variables are x's and z's. So I have 1, 2, 3, 4, 5, 6, 7 x's. There's 7 x's. 3 of them match up, so that's x to the 3rd with an x underneath here. And I'm going to do the same thing with z's. 1, 2, 3, 4, 5. That gives me 2 pairs of z's. Those guys come out, leaving me 1 z inside. Remember, when you simplify these, you should never have more than one type of variable in there. So you can have 1x and 1z, but you couldn't have like x cubed or x squared or anything like that. If you see that on a simplified, you can immediately get rid of that. Number two is, you guys were very, very good at this. You guys are simply going to make it from simplified form and put it back into radical form. So all you're going to do here, remember, when you take things out of the dryer, you want pairs of socks. Okay, right here you have a pair of 6s. So you're going to put the pair of 6s back in. So you have 10 times 6 times 6, and that's all in the radicand. 10 times 6 is 60. 60 times 6 is 360. Okay, I know that because 6 times 6 is 36, and I know I have a 0. So my radicand is going to have 360 on the inside. Okay, that's how you finish up this one. And again, we're going to finish up with just a couple of these expressions. All right, so these expressions are things that when we write it out, and you're going to see in this next unit that knowing how to write it out is going to help us. It says the half the sum of a number and 6. Okay, half the sum of a number and 6. Okay, so it's going to say the sum of half a number and 6. Excuse me, I read the wrong one. The sum, that's plus, of half, 1/2 number, so we'll say n and 6. Okay, so that's simply exactly how it's written. Half, the sum of half a number, so that's 1/2 n plus 6. The sum of half a number and 6. 1/2 n plus 6. Okay, number 2, it says half the sum of a number and 6. So, where this is different is it has a half here, and then the word sum out here. So you've got to really read it. Half the sum of a number and 6. So this is going to be a number and 6. Again, these are very, very close, but half the sum of is going to be 1/2 the sum of n plus 6. Okay? The sum of a number and 6. All right? The other one said half the sum of a number and 6. So, very, very close, but keep those in mind and how those are written out, because you're going to have some similar. And the very last problem, we're just simply putting in replacement variables here. All right, and we're going to be doing more of this as time goes on. So you have 5 And last week I didn't do this as beautifully as I should have. So 5x minus 3 minus 3y. Okay, now I'm going to put in for my variable. So the numbers stay 5 parentheses, and this is 6 minus 3, and then I have minus 3 times negative 1. Okay, 6 minus 3 is 3, so this new number is 3, and we still have that 5 minus 3 times negative 1 gives us negative 1, which is a trick, and you're going to consistently see this trick where you have a negative and a negative, and then you, as your answer, you're going to say 5 times 3 is 15 minus a negative 1, which actually is 15 plus 1, because minus a minus is a plus, and that gives us 16. So the answer for number 3 here should be the number 16. Hopefully this helps you guys. We have a test tomorrow. I want to give a shout out to Tyler Scott who filmed this for me. Hope to see you guys do well tomorrow. Good luck.